Help files for chapter 6. We're going to start with number 70 where we have the car. We started it in class, but here we go. So the car, as you see, we're given the mass of the car, we're given the constant speed, and they compare the power that the motor has to have or produce while going up and going down. They also say that this retarding force, which is force of friction plus air resistance, is exactly the same whichever way it goes. So overall, as you see, mg is consistent, normal force is consistent, retarding force is consistent. It's the motor has to produce different amount of work, and therefore its power is going to be different. So we need to figure out the angle theta of the incline up or down which the car is moving. So that's the angle that we're figuring out. So as you see already, I have all the free body diagrams, so we know that since the object is moving at a constant speed, then force of the motor, or net work for that matter, is going to be 0, so therefore the work done by the force of the motor should be equal to the work done by the retarding force and mg in this direction. Or if the object is moving downwards, then force of gravity plus a little bit of the motor will equal the force, if we're talking forces, or work done by the motor plus work done by gravity. Those two works have to equal the work done by the retarding force. So work of the motor going up equals the work of the retarding force plus work of gravity. The work on the way down from the motor is less because it just has to provide the difference between the work done by the retarding force and the mg, because mg is doing us a favor. It's moving, it's working in the direction of the motion of the car. So just to make it clear, so this is up and this is down, on the way down and up. So if I were to compare the powers, the power of the motor is work over time. So there we go. I'm just taking this as your work of the motor going up, and the power of the motor on the way down is the difference between these two works over time. So that's about where we stopped. So continuing that, the power of the motor on the way up, the power of the motor on the way down, and we know the difference between those two. So if I know the difference, which is 47 horsepower they gave us, then if I take these two fractions and they have the same denominator, so I can write them as 1. So that's the positive part, that's on the way up, that's on the way down. And once I distribute, I end up with, this goes away because it's plus and minus, and they're the same, so therefore I can subtract. And then minus and the minus gives me a plus, so I have two works of gravity over time. So the work done by force of gravity is mg delta x times cosine. Technically, if I were to do it the right way, so that's my displacement and that is my force. So the angle between the displacement and the force is going to be 90 minus whatever this is, if this is theta. And so, but cosine of 90 minus theta is sine of theta. So I'm rewriting this as mg delta x sine of theta. And then I'm just taking this whole thing, contraption right here, and I'm plugging it into this one, which is right here. So 47 horsepower is going to be 2 mg sine of theta times delta x. And then delta x over delta t is our velocity, and they gave us velocity. So therefore we have this, and theta itself, which we're looking for, is the arc sine or inverse sine of 47 horsepower divided by 2 mg times v. And again, 47 horsepower has to be in joules, so we'll multiply it by technically 745.7, but I'm just rounding it to 3 sig figs. And that gives us 2 degrees